So, fourth lesson. Okay, this is where things are going to get interesting. What am I doing? So, we left here. That was our code, if you remember, and we could continue adding points on top of other points. But of course, this is stupid. I mean, you could do that, but why? Let's imagine instead a case where you want to continuously add points without having to always refer to the previous position and then add this vector to the new position and so on and so on. So this is where we can take advantage of feedbacks, and in this case in Houdini we can take advantage of a solver. So don't worry about those nodes, I just dropped them and I will show you later. A solver is a node, of course, and here if you jump inside, if you dive inside, you see previous frame and an output. The solver is capable of reading the previous frame, and so we could take advantage of this feedback, because read the previous frame, add, for example, add something, and then read the previous situation again, and then add something to what we have added before. So this is the concept of feedback. And maybe we can try to take advantage of this solver node to continue to add point on top of other points. But we need to be careful, because we said that our currently processed geometry is only this one. So how can we take advantage of a solver? For example, if inside of a solver we wrote this, we write this stuff. So let's copy this and let's dive inside. Let's connect the line to the solver and let's see what happens. You see you have the line and the solver is with the blue flag. If you dive inside and drop an attribute triangle that is running over points and you paste the code, let's see what we have. So we have a vector that is called add to position, which is set to be 1, 0, 0, and we are saying add to our current point position this vector, and let's see what happens. One thing that I have to tell you is that you have to toggle this. You have to click here, real-time toggle, just below the play button in the timeline. And here, press the real-time toggle, and the simulation now is going to be at the correct frame FPS and frame per second. And now if we press, don't press play, reduce this to as little amount, let's say 20 for example, so the simulation is only 20 frame, and let's press play. Okay, let's press play and let's see what is going on. So sorry, I'm not adding a point, so nothing is going on actually. So let's also copy and paste this add point line. Okay, let's see what happens. Okay, so we are spawning lots of new points, and I mean this can be considered correct. Let me disable this display point number just to see the points. This look correct, but there's a problem. So the problem is that every frame we are actually considering a new start, okay, because we are considering the previous frame as the input geometry. So the input geometry is the previous frame, which means that when we refer to at P, we refer to the state at the frame that we are currently working. And every frame, the state is changing, of course. And for example, here at this frame, we have this state, and of course, if we add to pose, the position attribute is now calculating for those points, yes, but for those points too, those points and those points. That's for those points we are fine because we want to spawn new points and progress, but we don't want duplicates. It's not good to have duplicates here and here and here. So we have to find a way, because in few frames the simulation will explode because too many points are going to be spawned. Let's check. Now we see 3, 6, 9 and 12 points, but actually we have no, we don't have. Oh, sorry. We have 24 points. 3, 4, 3, 4 is 12, and 3, 6, 9, 12. We have 24 points. This is not good. We are duplicating, but we have duplicates, and we don't want them, because here the simulation already has 384 points, which of course we don't see them, but if we check, we will be able to see that there are overlapping point numbers, and that's not good. So I hope you understand that what you plug in there is what this position refers to, and if you plug the previous frame, which you have to do because you want the feedback, if you plug the previous frame, the currently processed geometry will be every frame updated, and will be every frame a new state, and you will be adding to all of those points position your vector add position, and therefore you will have duplicates. So we have to find a way to mark what geometry we want to process and where do we want to actually add points. And how do we do that? One trick is to use, there are many ways, but one trick that I have learned from Junichiro Orikawa, which is a good resource for VEX, and I really suggest you to see to follow some of his live stream or tutorials or whatever they are. They are really long videos, and so maybe it's not that good for beginners, but if you follow my tutorials, then if you understand what I'm doing, if you get confident, then you can follow his tutorials, which are well, they are not tutorials, but his videos, let's say his videos. So let's try to do something. In Houdini, you have the possibility of taking advantage of groups. A group is a node. I mean, a group is not a node, but you can use a node to group points, and you press tab and drop a group node. Sorry for the chaos. By the way, if you want to align nodes, just click them and press L. And if you want to change this, I don't know, visualization, press Shift S, and you see you have curvy wires, while instead of those, which I don't know, I prefer to use those curvy wires, but it's up to you. So let's drop a group and let's see what a group node is doing. So as you can see now, our points are getting yellow or orange, and the group by default is grouping primitives, and the group name is called group 2. We want to group the points because we want to work on points, and we want to give it a name, a better name, and let's use process, because those will be the points that we want to process. And of course, if you consider that now this is your initial geometry and you imagine the at p attribute, the position attribute, so at p, not a variable but the attribute, of course we are working on those points as we were doing before in this case, okay? This is referring to this geometry. And so if we work on process point, here is exactly the same stuff. But if we can somehow make this group proceed, and while it is proceeding, it is also, points are also being removed from the group every frame, the state of the simulation will be only process the points. I'm gonna show you, because maybe it's a little bit hard to understand at the beginning. So let's try to work only on process points. So here inside the solver, let's work on process. And at the beginning, the initial state is of course fine, because we are working on process points, which are those points. Even though we were not working on process points, the initial state was fine because we are working on those points the same. But now we want to put this new PT inside of the process group. And at the same time, so new PT are those points. At the same time, we want to remove those points from the process point group, because here we are saying only work on the points that are inside of the process group. And how can we do that? We can set point attribute, set point group. You can imagine from the name set point group, let's set a point group. Let's set for those points that are called, that are identified by the new pt integer, let's put them inside of the process group. And how do we do that? First of all, we need the current geometry that we are processing, the current state we are working on, and this is geometry stream 0, which is our previous frame. And now we need the name of the group, but you have to do like that. Use this bracket. No, I don't know the. No, I don't remember how do you call those stuff. In Italian we call them virgolette. This is virgolettato. So inside what is the name of the group? Process. And what point do we want to consider inside of this group now? New pt. And we want to say that this is going to be inside of the process group. Now, at the same time, we want to set point group 0, again, process. Our currently processed point should be removed from the group. ptnum should be removed from the group, so 0. So imagine this state of the simulation. The ptnum, as I told you many times, like p, the same stuff, ptnum is referring to the current state that we are processing, and the current state at the moment is this one. Don't consider those points, because those points are spawning because the code is saying to spawn, and this is the first frame, and the solver is already starting from the first frame. There's a way to fix this and start from 0, so start from exactly seeing only the current processing geometry, but for the moment don't worry. Imagine that we are adding the point, and now we need to put those points inside of the process group, and this is what we are doing, and we need to remove those points from the point group, because this at frame 2 will be frame 2 will look at the previous frame, and it will see two those points and those points too, and so the position will be considered for those and those ones if we were not using this trick. It's not a trick, it's just how things work. So we can take advantage of this process of this grouping stuff, and we can say, okay, every frame remove the current processed point and only consider inside of the process group that we are working on, and consider the new pt. And new pt is of course spawning every frame, because every frame we are doing p plus add to position, and again this p attribute is referring to the currently processed geometry, which is in this case, because we are specifying to process only the process group, will be our new points and not our old points. I hope this is correct. If we press play, we can see that now we have, let's check frame 6. Sorry, let's check frame 3. Let's check frame 4. We should have 14 points as the number is showing, and let's see if it is true. And yes, we have 14 points. I mean, we have 15 points because we are starting to count from 0. So 14, but it's starting from 0. So it is correct, 15 points. Let me know if you have any questions, and you can, of course, run the simulation for more frames and zoom out to see the result. And points are spawning infinitely and in the correct way, without overlapping, without duplicates. See you in the next lesson. Oh.